Okay, so welcome back. Today we're going to be talking about simple interest. So, what is simple interest? Simple interest is interest calculated on the principal. What does that mean? That means that when you have simple interest, you have a base amount or a principal that you would invest or borrow, and on that base principal, you would increase it or decrease it by a common ratio. So, for example, what that means is if you have $100 and let's say you invest that $100 into a bank, and the bank says that you're going to get a 1% return each year, right? So let's write this down and see if we can work on it. Just as it'll be much easier to understand as a written example. So let's say you have $100, right? And you put it into a bank. So you take this $100, deposit it into a bank. All right. So, and then at the bank, let's say the bank gives you 1% interest rate, and then so that means that each year you'll get 1%. Your money will increase by 1%, right? So, so after then, what this would mean that after 1 year you would have 100 plus 100 times 0.1. Okay, so how did I get that? Let's quickly look at that. So 100 because this is your original amount, so that is your original amount. You have that. Then you have this, which you get because um, so you get this because your money is going to increase by 1%, which means that if you sorry, oh, then I did this wrong. My bad. It is 0.01 because yeah, it's 100 times 0.01 because if you take 1, divide that by 100%, you get 0.01. Okay, so you have that. So your money's so as we know that if you multiply 0.01 by 100, you'll get 1% of 100, right? So then what that means is that you would get 100 plus 1, and that'll give you 101. So that means after the first year, you'll have this much money in your bank account. So that's how much will come back to you if you were to withdraw it. So it'd come back as a $101. Um, so that is pretty much simple interest. If you look at it, this is the principal, you would say. Sorry, this is the principal because this is the original amount that you had that you invested. So that's the principal. Then you look at your percent. The percent is always the rate. It's the rate or the interest rate that the bank gives you. And let's just look at the go back to the define PowerPoint and look at these keywords. So like it says here, you have simple interest, and you have the principal, the interest rate, and the amount. So if we were to go back here, we can label all the things that we had. Okay, so let's look at the principal first. So principal was $100. Put that there. Okay, next you had your interest rate. So let's write that down too. In this little example that we did, you would say interest rate is 1%, and in the calculations this means that you would use 0.01. And the last thing we looked at here was the amount. So what is the amount? The amount would be, in this case, 101. 101 was the amount. So the amount was 101. All right, so let's quickly sum that up, and then we'll move on. So if we look at the definitions here, you see that the interest rate is the percent of the principal that is earned or paid as interest. The amount is the sum of the principal and the interest. So pretty simple. Essentially, it means that a simple interest is interest where a specific your money is increased with a common ratio each time you calculate interest on it. So that's usually once per year, right? So yeah, it just pretty much increases like that. All right, so now let's look at the formula. Before I show you the formula, I think we can just derive the formula from the example that we did here, right? So in this case, we had the principal. Let's say principal is equal to P. So we had a principal. Then we had an interest rate. So let's say let's say that's I, correct? All right, so now we're clear on this, right? This is P, this is I, and then let's say this is the amount. So that's A. Now we've already used the equation. So now we can just instead of subbing numbers in, we can sub our variables in and get a general equation for it. So if we have A is equal to this, right? Because we found this is all equal to A. because it's equal to 101, right? So that's all equal to A. Then A would be equal to 100, which is the principal. We can put P up there, plus the 100, so that's principal again. And then times I is interest. So now we have this formula. So let's move down a little bit and write this formula down. So we have A is equal to P plus PI. That's what we have so far. But if we take a look at this formula in a little more complex way, we see that it won't account, it's not general formula. It won't give us the answer for all our equations, right? Or all our scenarios. And that's because this only works for the amount of money you've earned after 1 year. Because if we look at it again, we had 100 plus 100 plus, sorry, not plus, times 0.01. This only gave us the amount after 1 year. So now we have to introduce the factor of time into this equation, and we can do that really easily actually, because if we take a look at this, simple interest is really simple, and this is really simple. And the reason for that is because if you have, if after 1 year, so after 1 year, right, this is the amount after 1 year, you have this much, then after 2 years, you should have how much? This much times 2, correct? So all of this times 2, oh, these are the colons, they just simply mean the same thing written again. So if you have all this times 2, that would be your amount for 2 years, right? I mean, really simple. If you do that again, after 3 years, you would just multiply by 3. So that will give you 3 years. So what it would be the general formula. So let's say that time is equal to t. So for in a general sense, it would be multiplied by t for t years. Now we have our equation, and we can write it down. So what we have from this is A is equal to, let's say, P plus P I T. Okay, so now let's go back to the PowerPoint and look at what we had here. We had simple interest formula is P plus PRT. Okay, so we used a different variable than what was supposed to be used. So let's say that I is equal to R, and then the formula is A is equal to P plus PRT. But if you look at it, it's the same formula, right? So you can see how easy it is to find simple interest. You know, I mean, it's not that hard. You have your principal, your interest rate, and your time. That's it. Nothing else. You don't need anything else either. That's all you have. Just give it 1 second here. Okay, so your interest rate. Oh, okay, pen. So you have your interest rate, your principal, and your time. That's really easy. All right, let's move on now. Let's move on. Let's do an example quickly. So if we just click here, let's don't look at the answer yet. We're gonna do this over here. Okay, so how much space do we have here? A lot of space, I see. Okay, so let's paste it right here. Oh, I see what's happening. Okay. Control V. Can you move this up? I can't move that up. Okay, so let's just scroll it over and do that. It's a really simple question. Once we'll start, you'll understand it. Okay, so let's write this down. So John invested $5,000 towards his future education when he was 14 years old. Okay. How much money would he have by the time he was 18 at a simple interest rate of 5.8%? Okay, let's look at this now. Let's look at what we have. Let's look at some keywords. You'll see it's a really easy question once I start. So what is our principal? We can see that he invested $5,000. So that principal is obviously going to be $5,000. Okay. And then let's look at the interest rate. It's right here at 5.8%. And we have a time frame here. We have from 14 to 18. We can derive time from that pretty easily. So let's write it down quickly, just to write it down. $5,000. R is equal to 5.8%. 8%, divide that by 100, and we'll get 100%, and we get cross percent at 2. This is the number in our calculations is going to be 0.058. Simple enough. Now let's look at time. So we have from when he was 14 years old, so he started at 14, and until he was 18, or by the time he was 18. Okay, so now let's see what we include here. We include the summer of 14, or sorry, the year 14 isn't, so let's look at this. So he invested towards his future education when he was 14 years old. So his future education. So at 14, his 14th year, let's say he put his $5,000 in right at the beginning of 14. That means by 15 he would have 5,000 plus PRT. So at 14, exactly 14, he has $5,000, and at exactly 18, he has 4 years worth of money invested. So it's gonna be 5,000 plus PR4. Key number 4. So because he has 4 full years, 14, 15, 16, 17, and then the 18th he withdraws it. So the 18 doesn't count, but then the 14 does count. So you have 4 full years. So T is indeed equal to 4. All right, now let's move on to the equation. Let's write our equation down and see how easy it is to sub these numbers in. A is equal to P plus PRT. What's P? It's 5,000. Leave the units out for now. You don't need them. Plus 5,000. And then we have R, which is 0.058. And you have time, which is 4. Okay, so I'll just do this on my calculator right here, quickly. It's not that hard. Calculator. Alright, so let's do this now. We have 5,000 multiplied by 0.0058 equal that, multiply it by 4 equal that, and then add it to 5,000, and you get 6,160. So is equal to 6,160. Oh, excuse me, I forgot to. Now we'll include the 6,160. All right, yep, dollars. So therefore, let's look at how much money would he have by the time he was 18 at a simple interest rate of 5%. Therefore, John will have $6,160 by the time, actually. By the time he is 18, the time. So that means that his 18th doesn't count. So by the time, let's close this over here. By the time he is 18. Simple enough. Okay, so not too hard. Let's move on now. Oh, we have our other work there too. Go over this way. Okay, so now let's do a counter example of this to make sure we understand it, right? I mean, there's no harm in doing one of these as well. Okay, so we gotta paste it again. I'm just gonna move it over here this way. I found a way to get around it. Huh. Alright, there we go. Alright, let's take a look at this question now. So, Mary took a loan of $400,000 at a simple interest rate of 5% from the bank for going on a world cruise. How much money would she owe the bank if she still has not paid back the loan 7.5 years later? So, once again, let's look at our key values. We have a loan of $400,000 right off the bat, so that is going to be our principal. We now know how easy this is. This is an interest rate of 5%, and her time is not paid back the loan in 7.5 years. So we have a time, principal, and an interest rate. So our principal is equal to $400,000. Our interest rate is equal to 5%. Let's divide that by 100%. Cross is equal to 0.05. And lastly, our time. Our time we know is 7.5 years later. Okay, so now let's write down our equation. We have A is equal to P plus PRT. Alright, so I'm going to do this question now, and I want you guys to, as I finish, try to see what the mistake I make is, okay? Because then I want to see if you guys can get it before I explain it to you. So we have a principal of 400,000, and then we have 400,000 again, times 0.05 times, oh, we're running out of space, so a little bit. Times what? Times 7.5. Okay, so now let's do this on a handy dandy calculator, as my partner often says. Calculator's not moving. There we go. Okay, so we have 400, 1, 2, 3, 4, 400,000 times 0.05 times 7.5. And we get 150,000. Now let's add that to 400, 1, 2, 3. And we get $550,000. Okay, so let's write that down. 500, oh sorry, I don't know, what did it say? It said 500, 5, 5, 1, 2, 3, 4, $550,000. Okay, excuse me there. 500, 1, 2, 3, 4, 550,000. Huh, lost the number there. Okay. So now I'm wondering if any of you might have caught the mistake by now, but if you haven't, let's take a look at it now. So let's go back to the question and read it. So it says that Mary took a loan of $400,000. Okay, so that seems right until there. At a simple interest rate of 5%. 5%. I mean, you can't really go wrong from there. From the bank for going on a world cruise. How much money would she owe the bank? So how much money would she owe the bank if she still has not paid back the loan 7.5 years later? Seems right enough. But the trick to this question is this right here. 7.5 years later. In terms of simple interest, if your interest is calculated each year, right, as it is in her case, you wouldn't do decimal places for the time, because you would have whole numbers for time, because of, you know, like if it's calculated each year, then it's at 7.5. She still has only accumulated 7 years worth of interest. So if you haven't understood that, let me explain it once more in a more basic manner. 7 years worth. Okay, so her interest, simple interest periods are per year, right? So at 7 years, her interest has only been added 7 times, because the 8th time hasn't happened yet. So that makes perfect sense now. Now we can go back and do this question again, but with the correct numbers. So let's cross this 0.5 out, because it's only been 7, technically to the bank's interest periods, it's only been 7 years. She could have paid it back at 7 and like 3/4. It still would have been 7 years. So now we have 400,000 again, plus 400,000 again, times 0.05 times 7. And now we will get the right number if we use our calculator. So what are our numbers? 400, 1, 2, 3 times 0.05 times 7 is equal to 140,000. So as you can see, it made quite a substantial difference. I mean, we were $10,000 off. So now we have plus 50. Sorry, not this. It's plus 400, 1, 2, 3. And we get $540,000. So $540,000. So therefore, she will have to pay back $540,000. 140. I'm just adding this on. You don't have to write this in your therefore statements. $140,000 of which will be, so therefore she will have to pay back $540,000. $140,000 of that, actually, of that will be interest. So now you can see it's no joke. I mean, like, paying back on time is like a really good thing to do, because then you save, as you can see in her case, $140,000, and this isn't like out of the ordinary. Well, actually, I guess 5% is a really high interest return. Yeah. So so that is simple interest. I mean, as you can see, it's really easy, really simple, if it were. So I mean, thank you for watching our videos. We hope to see you back next time with more mathematical concepts.